So, welcome to our first episode for Econauts. My name is Simon, and I'm here with my brother Ben, the Rocket Man. We
Stop
are
it.
we are talking in our show about science, space, and economy, and our topic today is spaceports. My first question: what is a spaceport?
Well, I guess the name is quite self-explanatory. A spaceport is pretty much a port, such as, for ships or like an airport, but obviously it's for vehicles which go to space. So it could be something on Earth, could be something on another planet, could be something in orbit of another planet. So anything which pretty much allows you to manage space vehicles, I would consider calling a spaceport.
That leads me to my next question in regards to spaceports for location. So you already mentioned it could be in space, could be on a planet, but I would assume that there are certain locations better suited for a spaceport. Like, you wouldn't put a harbor in the middle of a desert, obviously.
Exactly,
So,
yes. Yeah.
right, and also if you have an airport, there are certain locations better suited. You wouldn't put an airport for a big airplane on a huge mountain, for example, right? So I can assume that the same applies for spaceports as well. Maybe you can tell us a little bit about location.
Yes, that's exactly right. For the purpose of this talk, I would also say we focus on spaceports on our planet.
Yeah,
So obviously, otherwise this goes too wide into
yeah,
other topics. On Earth, there are certain locations better suited than others. And to start with the basics, our planet rotates around its own axis, and therefore anything which is close or at the equator, if you don't consider any other conditions, would be the best location for it. Let's assume our whole planet would be just land. Then you would be building your spaceport anywhere at the equator. The reason for that is that because of the spinning of our planet, you get the most extra energy, most momentum when you launch something into space from the rotation of our planet. And therefore you use less energy, less fuel in order to get off the planet. And then additionally to that, so if that would be the only criterion, it would be simple, right? But obviously we are not just land, we have also ocean. Therefore that limits already the spots. Directly at the equator, the weather conditions usually are not very well suited. So you have lots of hurricanes and bad weather conditions. So obviously you want to find something where the weather conditions are suitable to launch almost every day. And then obviously the last part, which is a group of requirements and conditions in one, are geopolitical in nature. So let's say you would build it in a country where there's lots of war or where a lot of people are living, then that's less well suited than a location where almost nobody's living and where there's peace.
absolutely. Just one more thing. So in terms of the rotation, if I understand that correctly, we are basically using the rotation of the planet to our advantage. So it's just like a slingshot, right?
Pretty much, yes. So in order to get into orbit, although rockets usually start vertically, at some point they go horizontally. And what you want to do really is you want to be as you want to reach the speed so that when you would consider you would be thrown, that you are falling over the horizon and you maintain that speed to continue to fall over the
Yeah.
horizon. And that's when you sort of go around that. If you are starting closer to the poles, then you have to get to the speed additionally with your propulsion system. But if you are close to the equator, then you have that extra speed already from the rotation. Obviously, you need to launch in the right direction. If you launch against the rotation, then you would have to overcome the rotation extra. So if depending on which direction you launch, but nobody would really launch against the Earth's rotation. Um, you know, that dictates more or less how much energy you will expend in order to reach orbit in the first place.
See, would that also apply for a space station in space? So, if I have my space station over the equator, is that better, or let's say not better, but is that um, a better option in a long run, or is that doesn't really matter?
Once you are in orbit and once you
Yeah.
have reached the destination orbit, it doesn't really matter anymore. But to get to this orbit can be very expensive. So if you deliver, so imagine you have you want to put your space station or your spaceport, well, your
Spaceport.
spaceport in orbit, then you obviously you have to reach the destination first, right? So
Yeah.
now consider you launch from an equatorial launch site, and you are reaching your destination in the equatorial orbit, then you're there already. So you don't
Yeah.
have to expend any more propulsion and energy. Anything diverting from there is extra energy. So long story short, obviously, in order to save as much energy as possible, you would put it in an equatorial orbit.
So my last question is the economic significance for having a spaceport on Earth.
Yes, so I think that's a very interesting topic, and it's a lot. There's a lot of dispute and discussions currently going on. First of all, a lot of people think that polar launch sites are a good idea. I personally believe that it's not the case. You're limiting yourself already what orbits you can reach, and also the market share is very small because a lot of people have that idea and want to do this, so therefore you have a lot of competition. On the other hand, equatorial launch sites are very limited for said reasons at the beginning of this show, and but you can't just transfer your launch location at some point. Once you have established your spaceport, I would say the economic significance is extremely high. So from historical data from other spaceports, and a good example is the spaceport in the Kennedy spaceport.
That is located
has
where?
been built in well, what did I say? The Kennedy, yeah, in Texas. So,
Okay.
oh, sorry, I was somewhere else in my head already. From that location, so first of all, the location is only suited for horizontal launch,
Yeah.
and no launch has been happening from there so far. The spaceport has been established, if I remember correctly, 2019. And so far, about $300 million has been invested in the location, and yet the economic output of the location is about $1.5 billion. Intuitive Machines headquarters there, and Axiom headquarters is there. So my point here is a spaceport triggers a lot of economic activity in the region. Depending where you build it, there's also a lot of spaceports who have not reached that goal because they have not built it at the right place. And Kennedy obviously has a very close proximity to where most NASA rockets and SpaceX rockets are launched from. So obviously there's a very close relationship there.
So when we just look a little bit into the future, because I think one thing that might be interesting to know and to explore is also, I mean, now we built the spaceport and now we're launching rockets into space, but what is the impact for us as human beings? I mean, having science, that's one thing, obviously, but at some point we also maybe want to know what do we get in return for investing so much money into launching ourselves into space? What's the benefit for us as humans?
Well, I could literally now have a pergament roll of things and unroll it, but in order to keep it short, first of all, if anybody believes that solving things in space is purely for research, I can tell you we are a tiny particle of dust in the universe. Solving things on our planet alone is very limited. So if we find solutions in space, we will automatically also find solutions on Earth. We will find things we have not even thought of, which will expand our technological horizon. On top of that, we have very limited resources on our planet. We have literally unlimited resources for our purpose in space. Yes, initially it's not, we can't reach all these the resources very easily. But at some point, once we have established and reduced the cost to get to space, and that's where in my eyes, the significance of spaceports and rockets and a highway to space more or less becomes clear. Once that is significantly less expensive, we have more and more opportunities to get resources back to Earth. And again, there's an unlimited amount of examples I can bring. Just a tiny one. If we would start to harvest helium-3 from the lunar regolith, that's the soil on the moon, we could use that helium-3, for example, if we crack fusion at some point, for so-called anerotronic fusion reaction, which would supply us with a almost unlimited amount of energy. Plus, it is sort of renewable because the solar winds always replenish the helium-3 in the lunar regolith. That's not happening on Earth because we have luckily an atmosphere,
Absolutely.
we have luckily a magnetosphere. The moon doesn't have that. And therefore, we could transport that back and forth. Yes, it would be for the next decade or so, it would be super, super expensive to do this. But once we have established that, we have so much energy we don't have to care about it anymore. So, and the list goes on, obviously.
I think one good example is if we look at a monitor, right? We used to have like those big monitors for our PCs. They were like significantly large and they were like super heavy. And I remember that having like a flat screen was like out of the question because it was like super expensive, right? And at some point, because the cost of building a flat screen, it's a lot lower than building one of those bigger monitors. At some point, I saw at the store both side by side for the same price because the price for one dropped so much and the other one was like unable to compete, and then it was like replaced, right? So I understand the concept behind that. I have one more question because I was like talking with my son about that before the show because he was asking me a little bit about what we are doing. And I was thinking, I know that there are certain challenges to overcome, obviously, but because you mentioned that it is like, also for our planet better to have like certain things, coming from space. Could we, in theory, also see that certain industries are relocated to the moon, especially because the moon, you said that yourself, has no atmosphere, which means that we would, technically, theoretically, not blasting any CO2 into our atmosphere, and the moon, because it doesn't have an atmosphere, would not be affected. So, you know where I'm going with that?
Yes, I mean, first of all, if you there's a lot of to unwrap here. If you would blast so much CO2 on the moon, then you would more or less generate an atmosphere at some point, which is then only CO2 around the moon. But I wouldn't even go so far. This depends on the industry. It would make sense to make most stuff on the moon, and definitely not for the reason to, avoid the pollution on Earth. There's way better ways to do that. For example, we should just stop, for example, to use gas, coal, and oil to make electricity. and instead using nuclear power. Everybody who in this day and age still believes that nuclear power is dangerous and a high pollutant, they don't understand the science behind it. It's very safe, it's clean, it's the cleanest way of producing electricity in the first place. So therefore, and if we reduce the amount of electricity produced from fossil fuels, we would already reduce the amount of, even from heavy industries, to pollute, because they are very energy demanding. If you would relocate all those heavy industries into space or on the moon, then you would still have to transport it back and forth. Therefore, you would just relocate the source of pollution to something else. In that case, then perhaps the rockets, which itself, if they're chemical propelled, would obviously emit some pollution and some gases into our atmosphere. So, but let's look at other industries. There are certainly industries which would benefit heavily from being relocated into space.
Yeah.
Two very good examples for that is the pharmaceutical industry. You can make lots of chemical reactions way purer if you do them in orbit than on Earth, because of microgravity effects or no gravity effects on the reaction. And another thing is, for example, for glass fiber cables. If you make them in space, you can make them purer because of having no gravity in the process, and therefore you make them more efficient. So you can make them longer and losing less energy in the process. So you make them better. So these are two good examples. The other advantages I see once you relocate things into space permanently is, first of all, if you want to build spaceships, you would build them in orbit. Because then you save already. You save already bringing them there. You just have to bring the material, but then you can assemble them there. If you then even have, I mean, that's now very futuristic, obviously, but if you can pull resources from space into orbit or wherever your dock is, then you can build it with materials you find in space, so in situ production. That makes way more sense than transporting things back and forth all the time.
Unless we have a transporter platform.
Let's if that is ever possible, that is obviously. But I think what I'm getting at is, once we overcome all these things, in order to overcome, we have to find technical solutions which will very likely have applications on Earth as well. What I'm talking about, like a very simple very strong example, is communication. In space, you always have low bandwidth, you always have latency issues, and you can have dropouts. Obviously, in order to have a safe operation for whatever you operate, you need to overcome. You have safety guards, you have maybe AI supporting you in your operations and so on. These fail-safe guards, which are generated for this purpose, they can be used on Earth as well. Imagine, for example, underground mining, where you also have dropouts. You have no permanent connection. You can't just teleoperate things there because of those facts. Overcoming them in space means you can overcome them there as well. Or submarine. In submarine, you have water is a very bad carrier for communication, for electromagnetic waves. They get dispersed very quickly. Therefore, it's a big problem, obviously, if you want to be in contact with your submarine. Submarine has to come up, and then you can communicate. So if we have fail-safe guards to help us in space, they might be applicable to those kind of conditions as well.
I very much like the when you mentioned that the AI can help us out with doing certain things in space. I think that's a very good point, because if we have like certain AIs available to us, we can obviously use them to make it much easier for us as humankind to have this dream of becoming a space nation easier for us, because certain things we actually don't want to do, right? As we don't want to be in I would say like I don't really see myself living on the moon unless there is like some sort of gravity, but if you have like and I'm just fantasizing here obviously, if I have like an industry set up on the moon that has like AI basically assembling certain things that will then be sent to Earth, I think it's a much better solution. You just have to send an engineer once in a while to do maintenance instead of having like an entire city on the moon, which might not be possible, because we also have to find a way to have like artificial gravity for us as humans to actually live there, right?
That's a very good point actually. So Dr. Gordon Rösler, for example, always recommends to have robotic space stations. It's a bit closer to us, obviously. And the notion here is at some point we want to do remote maintenance for satellites and space stations. So remotely operated from Earth, robots which are then floating in orbit for refueling missions and whatnot. And in order to logistically improve the whole process, it's a similar idea to having a spaceport on Earth. Having a robotic space station means you could store all your robots there and equipment and fuel, but you save all the human life support, which makes it way less complicated. It could be pretty much a floating device with a little bit of propulsion to stay in a certain orbit, but otherwise it's just a frame, and you can just sort of dock things on it, with a docking mechanism. And then a robot could come there and collect whatever it needs to then go to another orbit and service the satellite and refuel or whatever it has to do, or collect debris. As soon as you have to do life support for humans, it gets like 50 times more expensive and complicated, and you need like a 5-time redundancy if something fails, so that a human being who is then maybe located at the space station, like on the ISS, will survive, right? So a robotic space station wouldn't require that, because it's only made for robots. It doesn't require any life support.
Absolutely, and only because you have one doesn't mean you don't have the freedom to do the other as well, right? You could, in theory, even have like at the same space station one section that is like for humans, and the rest is basically done for AI, right? So it is possible to even combine those two, also for the benefit of humans, so that they don't have to do certain things themselves and can just let the AI do that, right? So I think that's pretty much clear, and that brings us very well to what we actually started in the beginning. So what is a spaceport? Why we need a spaceport, and why we should consider looking into space for our future. I think we had a very good first episode. I hope that everybody liked that, and if you do, please leave a like. And if you want to have more content, we are in the process of producing more. So please subscribe to our channel, and I wish you a good day. Thank you very much. Dr. Ben, the Rocket Man over there in Australia. All right. Thank you. All right. Bye-bye.
Thanks. Bye.